So welcome back to my YouTube channel. In today's video, we will be learning about angle between two curves. So the angle between two curves at the point of intersection may be defined as the angle between their tangents at this point of intersection. If the tangents are not perpendicular to each other, then such tangents form a pair of acute angles and a pair of obtuse angles. The acute and obtuse angle are supplementary. So we have here the formula tan phi is equal to the absolute of m2 minus m1. So m2 meaning to say that is a slope 2 minus slope 1 over 1 plus m2 times m1. So m means the slope. Okay, so note that if tangent phi is greater than 0, then the phi is an acute angle. And if tangent phi is lesser than 0, then that is an obtuse. So, however, it is customary to find any acute angle of intersection between the two curves. So take note that how do we derive or how do you get the formula tangent phi is equal to m2 minus m1 plus m2 times m1. Okay, so if we're going to have the two curves here, so we have the two curves. So let us have first this one. If this is the the Cartesian plane, so let us have first the first curve and the second curve. So if we're going to have this part, so we need to find the intersection, the angle of the intersection, which is the phi. So if we're going to get the tangent of this part, tangent of this one, this is tangent 2, and this is this is tangent 1. Okay, so we have here, this is tangent 1. So we have to find the slope of this curve 1 and the slope of the curve 2. So take note, if this is the angle, this is the angle. If we're going to locate this part, so if this is our theta 1, so therefore this angle could be our theta 2. Okay, so if this is theta 1 and theta 2, how to find the angle of this one? It's stated that remote exterior angle is equal to the theta, this angle plus this angle is equal to this angle. So therefore we have theta 2 is equal to theta 1 plus the phi. Okay. So therefore, if we need to get the angle of this part, we need to have phi is equal to theta 2 minus the theta 1. So it's stated that tangent is equal to the slope of the curve. So therefore, we have tangent phi is equal to tangent theta 2 minus theta 1. Okay, so take note, this is in a point O, x O, y sub O, and this part, this is our y is equal to f, the first function, and this one is our second function. Okay, so y is equal to our second function. So, and this one is vertical angles also, so therefore this is our phi. So if this is a phi, so we have to find how to find the angle for this phi. Phi is equal to theta 2 minus theta 1. So since slope is equal to the tangent theta, so we have to find tangent phi is equal to tangent times the tangent theta 2 minus theta 1. So by this identity, so tangent phi is equal to tangent theta 2 minus tangent theta 1. So this is minus over 1 plus tangent theta 2 tangent theta 1. So take note, m is equal to the slope or the tangent theta. So therefore, we could simply substitute. We have tangent phi is equal to m2 minus m1 over 1 plus m2 times m1. So other formula, it is being used as an absolute because if that is greater than the theta, so it is customary that we need to get the acute angle because they are supplementary to each other. So this is the formula. How did they come up with this? By this, okay, by this curve 1, and we have the curve 2. By the use of this part, this is angle, right? Angle of inclination, and this is the angle of also this part. So if this is the angle or the theta is equal to the slope, so therefore, how to get the phi? So to get the phi, just get the theta 2 and theta 1. So subtract this one, we could now get our phi. So that's why, So that is tangent phi is equal to tangent theta 2. Why we need to subtract? Because this part, if you're going to have this one, this is the slope or the tangent theta. And this is the slope or the tangent theta for theta 2. Since remote exterior angle is equal to, so this one, remote exterior angle is equal to phi plus theta 1. So if we're going to add this part and this part, the resulting of this one is the remote exterior angle. So in order for us to get the phi, we have to equate this formula. So theta phi is equal to theta 2 minus theta 1. So take note that m is equal to the tangent theta. So therefore, tangent phi is equal to tangent theta, tangent theta 2 minus theta 1. So this is trigonometric identity. So that trigonometric identity, so that one is when that is theta 2, that is the sum and difference of trigonometric identities. So you have theta 2 minus theta 1 plus 1 plus theta tan theta 2 tan theta 1. Tan theta phi is equal to m2 minus m1 over 1 plus m2 times m1. So we have, we also discussed this one during your analytic geometry, that is angle between two lines. But this time, we're going to talk about angle between two curves because this is all about the curves, but we derive this one using the line. Because the point here of the tangency, the slope, make it same slope to this part. The point of tangency of this part, the tangent 1 and tangent 2, we can have the same slope. Alright, so that's all about the formula. So take note how to find the angle between two curves. There are steps to be followed in finding the angle between two curves. So first is find the intersection. So take note, this is the first part, the intersection. Next is find the first derivative or the slope. Alright, and substitute to the formula. So first is find the intersection. Next is substitute to the find the derivative, first derivative, and substitute the formula. So we have I, F, F. Okay, so steps in finding the angle between the curves, we have the I, F, F. So let us solve number 1. Okay. So find the acute angle of intersection between two functions. So first step is we need to find for the intersection. Okay. Based in our formula, we need to find the intersection. So how to find the intersection to this one? So y is equal to x cubed plus x minus 8 is equal to, and y is equal to x. So therefore, we have y is equal to x cubed plus x minus 8. We could simply substitute to this form. X is equal to x cubed plus x minus 8. So the value of y becomes x because y is equal to x. So by cancellation, we could cancel this part. So therefore, we have x cubed is equal to 8. So x cubed, so how to find for x? X is equal to the cube root of 8. And x is equal to 2. So the cube root of 8 is equal to 2. And to find for the value for y, so y is equal to x, so therefore y is equal to 2. So therefore the point of intersection would be 2 and 2. Okay. So next step is find the first derivative of each function. So we have here first derivative of this part, so x cubed plus x minus 8. So y prime is equal to 3x squared plus 1. So since that is in the point 2, 2, so we have to substitute y prime is equal to 3 times 2 squared plus 1. So y prime is equal to 3 times 4 plus 1, that is 12 plus 1, that is 13. So the first slope is equal to 13. So we have here slope 1. And we have y is equal to x. So y is the first derivative is equal to 1. So since y prime is equal to 1, so we could not substitute the value for x here because that is a constant function. So therefore, we have this r m2. So now we come up with the two slope m1 and m2. Just simply substitute to the given formula. So tangent phi is equal to the absolute of m2 minus m1 over 1 plus m2 times m1. So we have here our m2 is, so sometimes if so that we cannot take the absolute, mostly that the angle is greater minus the lower. So we can have this part as our first and this is the second. Since naka-absolute po siya, and this could be interchanged. So we can have this one as 1 minus 13 over 1 plus m2 is 1 times 13. Alright, so we have here the absolute. So tangent phi, if we're going to use that one using your calculator, we have 12 over negative 12 over 14 rather, that is equal to 12 over 14. So therefore, we have here tangent phi is equal to the inverse tangent of 12 over 14. So inverse tangent is, you can have this one as 40.6 degrees. So we can have this answer or this one. So phi is equal to inverse tangent of 12 over 14. So the first step is we need to find intersection. Next is the derivative, first derivative. So this is I, first derivative, and substitute to the formula, which is the formula. So I, F, F. So that is all about problem number 1. So that is how to find the acute angle of the intersection between two functions. So that is example number 1. So you could have this one as 13 minus 1. Since acute angle should be the tangent theta is greater than 0. So we could have 30 minus 1 so that we could be able to get for the acute angle. Since this is absolute, so since that is customary that we have to get the acute angle. If that is obtuse is tangent theta is lesser than 0. Okay, so that is all about problem number 1. Okay, let's proceed with problem number 2. By the way, this is, before proceeding to number 2, this is the graph, right? So the angle between two curves. So if we're going to look at here, so this is the graph between the two, right? So we have example. So first is we have to get the angle and the angle. Okay. Next, problem number 2. Y is equal to x squared plus 1 and y is equal to x times x raised to negative 1. So the first step that we're going to do is find the intersection. So y is equal to x squared plus 1 and y, we could express this one as x plus 1 over x. So just simply y is equal to find the LCD. So we have x plus x squared plus 1. Okay, x squared plus 1. So therefore, the value for our x squared plus 1 is equal to y. So y is equal to y over x. Okay, so the value for x is equal to y over y, that is equal to 1. So therefore, the value for x is equal to 1. So to find for the value for y, y is equal to 1 squared plus 1, that is y is equal to 2. So the point of intersection is 1 and 2. So this is the first step, the intersection. Next is we need to find the derivative. So the derivative of the first is y is equal to x squared plus 1. So y prime is equal to 2x. Okay. Since at the point 1, 2, the point of tangent, we have y prime is equal to 2 times 1. So y prime is equal to 2. Right. So next we have y is equal to, derivative of this part is 1 plus 1 over x squared, right? Because we're going to take the derivative, negative 1, so that is equal to negative 1. By the way, this is negative. So this is negative. So negative x raised to negative 1 minus 1, that is negative x squared. So if we're going to rewrite that one, it will have 1 over x squared. So y prime is equal to, this is y prime, so 1 minus 1 over 1, so y prime is equal to 1 minus 1, that is y prime is equal to 0. Since mostly that is customary that we need to get for the acute angle, so therefore bigger minus this one. See, this is our slope 2 and slope 1. So in this case, we have the formula tangent phi is equal to the absolute of m2 minus m1 over 1 plus m2 m1. Why I take the absolute? Because it is customary that we need to get for the value for acute angle. So we have here the absolute of what is our m2. m2 is 2 minus m1, which is 0, over 1 plus 2 times 0. So the absolute, so inverse, the result of this one is equal to here, just here. So the absolute of 2 over 1. So therefore, inverse tangent of this part is inverse tangent of 2. So the answer is theta is our phi, rather phi is equal to the inverse tangent of 2. So therefore, the phi is equal to, you can have this one as 63 degrees and 63.4 degrees. So you can have this final answer, inverse tangent, but if we need to find for the angle, and this is for tangent, and this is for angle. So this is how to solve for problem number 2. So find the angle between two curves or the two functions. Alright, so we have here the answer. And this is the graph. So if we're going to look at the graph, so by the way, so if we're going to have this one, you need to find the acute angle. So this is the acute angle. We could have this one as, or where's the acute? So acute and obtuse angle. So first you could have this part, right? Okay, so that is how the graph looks like. Okay, acute because this is obtuse. Okay, so this is another, and this is supplementary to the acute angle. So that is how it looks like. If we're going to graph, just get the point of intersection first, the first derivative, and substitute to the formula. Okay, that is all about number 2. Next, we have problem number 3. So in problem number 3, we have x squared y plus 4y is equal to 8 and x squared y is equal to 4. So the first thing that we're going to do is to find the intersection. So if we're going to look at x squared y and x squared y, we can easily find the value for our y here. So x squared y plus 4y is equal to 8. Since the value for x squared y is equal to 4, so 4 plus 4y is equal to 8. So 4y is equal to 8 minus 4. So y is equal to 8 minus 4, negative 4, 8 minus 4, 4, divided by 4, 4 over 4, y is equal to 1. To find for the value for our x, we could have this part as x squared y is equal to 4. So x squared times 1 is equal to 4. X squared is equal to 4. We could have the two values, x is equal to positive and negative 2. Okay. So we have here positive and negative 2. So since both absolute, we could make use of 1 or we could make use of 2, but they have the same answer. Okay, so first is we need, this is the first process, and the second process, after getting the intersection, we need to find the first derivative. So in this first derivative, x squared y plus 4y is equal to 8. This is implicit. So x squared times y prime, this part will have the derivative, plus copy the y, and the derivative of this part is 2x plus 4 y prime is equal to 0. Alright. How to find for the y prime? So let's continue here. So x squared y prime plus 4 y prime is equal to 2xy negative. Okay. So y prime, we have x squared plus 4 is equal to negative 2xy. So y prime is equal to negative 2xy over x squared plus 4. So at this time, we have to substitute the value for x and y. There are two functions here. So first is 2 and 1, and we have negative 2 and 1. By substituting, we could have the result. So y prime is equal to negative 2 times what is our x? It have first positive, so we have to substitute first part times 1 over 2 squared plus 4, right? 2 squared plus 4. Y prime, if we're going to substitute negative 4 over 448, that is negative 1 half. Okay, if we're going to make use of the other one, okay, so if we're going to make use of the other one, so y prime is equal to negative 2 times negative 2 times 1 over negative 2 squared plus 4. So y prime is equal to 4 over 8. So y prime is equal to 1 half. The difference is the y prime is equal to negative 1 half and 1 half. So next is, this is the first derivative of the first equation. And first we need to find that first derivative of the second equation. So we have here implicit function. So we have x squared times y prime for the second function here, plus y times 2x is equal to 0. So we have here x squared y prime is equal to negative 2xy. Right, this is negative 2xy. Okay, so equals, okay, so y prime is equal to negative 2xy over y over x squared. Okay, so this is our y prime. So now we have to substitute here. So the value is equal to, first value we have negative 2 times 2 times 1 over 2 squared. So that is y prime is equal to negative 4 over 4, that is negative 1. If we're going to make use of the other one, so y prime is equal to negative 2 times negative 2 times 1 over 4, because x squared, that is equal to positive 1. So we can have the slope, the other one is the negative. Since the formula is equal to tangent phi is equal to, let us have first the greater one. So you can make use of the positive side. Here, we could make use, because since that is absolute, we could interchange. So we can have this one as, you can have, if we substitute using 2, and this is 2 and 2, so we have 1 negative 1 half m2 minus m1. So the formula is m2 minus m1 over 1 plus m2 m1. Okay, if we're going to substitute, we can have this one as the absolute of negative 1 half minus negative 1, so therefore plus 1. Okay, so plus 1 over 1 plus negative 1 half times 1. If we're going to substitute the 1, the resulting is 1/3. Okay, so therefore the tangent inverse, that phi is equal to inverse tangent of 1/3. Or we have the phi is equal to 18 degrees, 26, you could have 26 minutes, point 5.82 seconds. So if we're going to substitute that one, the same process, because still that is negative 1/2 and 1 1/2. So if we're going to have this one as tangent, alright, we'll write here. Okay, so we can have the same here. So we have 1 minus 1/2 over 1 plus 1 plus 1 times 1/2. Or if we're going to substitute that one, still this is negative. This is 1/3. So the same process here. So you have 1/3 and 1/3. So that is the answer for number 3. So that's all for number 3, and this is the graph for number 3. If we're going to look at, there is an angle of the intersection. That's why we have here the 2 points, because we have to get for this part and we have to get for this part. So we could simply use for this point here and this point of intersection. So the point here is -2 and 1, and this is +2 and 1. That's why we have here the two values, but still these are symmetrical or the same for this part. So I believe this is exactly the same angle. So that's why we could make use of this part, or we could make use of this part, but we could get the angle positive, that is acute, since angle is positive, since we could make use of this 2 1 and -2. So both are usable in this part. So this is how it looks like. Okay, so that is all about number 3. Okay, so let's proceed now with number 4. So in number 4, this is quite complicated compared to the previous example. So we have first in this part, we need to find the intersection. So in order to find for the intersection, so we need to equate one of the equations, whether y squared or 4x squared here. So which is most preferable? So let's try. So in this my case, we have okay. So we have here 4x squared plus 4y squared plus 5y is equal to 0. So since y squared is equal to 2x, so we have to equate here. So we have to substitute here the value for the result of this part, 4x squared. So find, so 4x squared is equal to negative 4y squared minus 5y. So x squared is equal to negative 4y squared minus 5y over 4. So x is equal to the square root of negative 4y squared minus 5y over 4. Okay, so y squared is equal to 2x. We have to substitute for the value for x. Y squared is equal to 2 times the square root of negative 4y squared minus 5y over 4. In order for us to get the square root, we have to square both sides, okay, by our algebra. So y raised to 4 is equal to 4 rather, times negative 4y squared minus 5y over 4. So nag-cancel po ang square root here, but this is squared, 2 squared, that is equal to 4, so cancel. So y raised to 4 is equal to negative 4y squared minus 5y. So y raised to 4 is plus 4y squared plus 5y is equal to 0. Okay, so if we're going to factor this part, this is the factor y times y plus 1 based on our algebra. So we have y squared minus y plus 5. So since this is not the factor of this one is not a real root, so we have y is equal to 0 and y is equal to negative 1. Those are real roots. Okay, so to find for the value for our x, just simply substitute here to the simplest function. So y squared is equal to 2x. So if y is equal to 0, 0 squared is equal to 2 times x, x is equal to 0. Okay. In this case, next we have y squared is equal to 2x. When this is negative 1 squared 2x, x is equal to 1 half. So the point here is 0, 0, and 1 half, and negative 1. Okay, these are the points that we're going to make use. But let's see which point do we need to use. So in this case, we have first, this is the intersection. Next is the derivative, the first derivative. So y squared is equal to 2x. Okay, so this is 2y, y prime is equal to 2. So y prime is equal to 2 over 2y. So we have to substitute the value for our y. Since we cannot make use of 0, 0 because it will be undefined here, so we'll make use of this point, 1 half and negative 1. So y prime is equal to 2 over 2 times negative 1. Okay, so y prime is equal to negative 1. So this is the slope 1. Okay, negative 1, and this is slope 1. And in order for us to find for the value for the second, the derivative of the second function, so we have here 8x. Okay, this is 8x plus 8y, y prime, plus 5y prime is equal to 0. Okay, so in order for us to get for y prime, 8y, y prime plus 5y prime is equal to negative 8x. So y prime factor 8y plus, okay, plus 5 is equal to negative 8x. So y prime is equal to negative 8x over 8y minus 5. 8y plus 5 rather. So y prime, substitute, since we will make use of this function at point 1 half and negative 1. So negative 8 times 1 half over 8 times negative 1 plus 5. If we're going to calculate this one, the result of this is negative 4 over negative 3. So 8 times negative 1 plus 3, that's negative 3. So negative 4 over negative 3, that is 4/3. Okay, so this is the slope of M2. Okay, so we have now the two slopes. So by the use of the formula, this is step number 3, our tangent phi is equal to the absolute of M2 minus M1 over 1 plus M2 M1. So what is the value for our m2. So m2 is equal to 4 third minus, it makes this plus 1 over 1 plus m2 is 4 third times 4 third times negative 1. So the result of this part, since 4 third plus 1 over 1 plus 4 third minus 1, if we're going to calculate, this is, okay, 7. So 7, since this is absolute and this is negative, it will become the absolute. So therefore, phi is equal to the inverse tangent of 7. Okay, the inverse tangent of 7. So we can have the final answer as inverse tangent. If we're going to calculate that one using your, if you're going to find the degrees, so just calculate inverse tangent of 7 so that you can be able to find for the degrees. So that's all about number 4, and this is the graph. So in this case, we did not make use of this part because the slope is undefined at this part at 0, 0, right? Undefined. That's why we'll make use of this part. So this is negative 1, I don't, 1 half and 1, negative 1. So again, why we did not use of this one? Because at this point, undefined po ang ating slope at the time of 0, 0, the point of intersection. That's why we'll make use of 1 half and negative 1 as our point of intersection, and that is point of tangency for this part. Alright, so let's proceed with number 5. Okay, so x squared plus y plus 4a squared is equal to a cubed, and x squared is equal to 4ay. So let us have first. So if we're going to look at, okay, so we have x squared plus y plus 4a squared, y is equal to a cubed, and x squared is equal to 4ay. So we have to find for the intersection. So since this is x squared, we have to substitute the value for x squared is equal to 4ay. So we have here x squared y plus 4a squared y is equal to 8a cubed. So in this case, we have the value for x squared is 4ay times y, okay, plus 4a squared y is equal to 8a cubed. Alright, so the value for this part is 4ay squared plus 4a squared y is equal to 8a cubed. Since we are going to find for the value for y, so first is we're going to factor for a. So this is y squared plus 4a y is equal to 8a cubed. So y squared plus 4ay, this will become 8a cubed over 4a. So y squared plus 4ay is equal to 2a squared, because this is 3 and this is 1. So 8 divided 4, that is 2a. So y squared plus 4ay minus 2a cubed, that is a squared, that is equal to 0. If we're going to factor this part, so by the use of our factor formula, so we have y plus 2a and y minus a is equal to 0. Since we need to get for the positive roots, okay, so y is equal to negative 2a and y is equal to a. There are two roots here, but if we're going to substitute for this part, x squared plus is equal to 4a squared, 4ay rather. So if we're going to substitute for the value for ay, it will become negative. And we're going to take the square root, it could not be. So that's why we need to find for, we need to use for y is equal to a. So x squared is equal to 4a times the value for y is a. So x squared is equal to 4a squared, and x is equal to the square root of 4a squared. So x is equal to positive and negative 2a. So these are the values, which is y, positive and negative 2a, and which is a. Okay, these are the values that we're going to make use. So these are the intersection. Next thing that we're going to do is we need to find the first derivative. So in order to have the first derivative, so this is x squared is equal to 4ay. So this 2x is equal to 4a y prime. So y prime is equal to 2x over 4a. Since the value for our x, so let us have first is 1, the value for x is 2a and a first. Okay, 2a and a, so that is equal to 2 times 2a over 4a. So that is equal to 4a over 4a. The value for our y prime is equal to 1. Okay. Next is we need to find for the value for our first derivative of this part. Okay. So this is implicit. So therefore this is x squared y prime plus y times 2x plus this is 4a squared y prime is equal to 0. So this will become 0 because this is part of the constant. A are those are constants here. So first we have to x squared y prime plus 4a y prime is equal to negative 2xy. Right? We transpose this to the here to the right side. So y prime is x squared plus 4a is equal to negative 2xy over x squared y x squared plus 4a. So this is cancelled now. So y prime is equal to negative 2xy over x squared plus 4a. 4a squared rather, 4a squared. May squared pala ito. Squared. So now we have to substitute the value. So y prime is equal to negative 2 times our x is 2a and the y is a over x is 2a squared and plus 4a squared. So we have here negative 2 times 2a plus times a. The result of this one is negative 4a squared over 4a squared plus 4a squared. So this is negative 4a squared over 8a squared. So the result of this one is negative 1/2. Okay, so negative 1/2, and we have here 1. So if we're going to substitute the value for negative 2a here and a, same concept the previous example that there are two and we could make use of one because they are just reflection to the other. So just make use of 2a and a. So if ever, but you can make use of negative 2a and a. It's up to you, but I gonna use 2a and a here. So in order for us to get the angle, so tangent phi is equal to the absolute of m2 minus m1 over 1 plus 1 m2 m1. Okay. Okay. So m2 minus m1 over 1 plus m2 times m1. So take note that in order for us to get the acute angle, so we have to take the absolute, or it should be the the bigger slope. The biggest slope will be the m2 and the smaller slope will be the m1. So in this case, our m2 could be 1 or negative 1. Since this is absolute, it is interchange. It could be uh, it could be it could be interchanged because that is absolute. That is customary to get for the acute angle. Okay, so we have the absolute m2. So we could have 1. So my negative may maging siyang plus 1 half. The absolute over 1 plus 1 times negative 1 half. Okay. So the result of this one is 1 plus 1 half. If we're going to calculate that one, that is 3. So therefore, the phi is equal to the inverse tangent of 3. Okay. Inverse tangent of 3, use of your calculator. So that is inverse tangent of 3. So this is the angle between x squared y plus 4a squared y is equal to 8a cubed, and x squared is equal to 4ay. Again, the first step is we need to find for the intersection. Next is find the first derivative and substitute to the formula. That is IFF. Alright, so that's all about number 5. So this is try this. Okay. Find the angle of intersection between the curves x plus 2y minus 3 is equal to 0 and y is equal to the square root of x. So I hope everyone you learned something from our discussion today all about angle between two curves. So if you have some comments and suggestions, you may comment there in the comment box if you have suggestions or comment with regard to the solution that I have today. And of course, ladies and gentlemen, I am requesting you to subscribe in my YouTube channel because someday I'll be having a next sponsoring that I'll be giving free load to those who could solve for try this by next time. So if I'm gonna reach for 1K subscriber, so someone will sponsor for 1K subscribers, someone will sponsor for the free load for try this next time. So if you're gonna have a Gusacto 90 or etc. or Scusurf or GigaSurf and whatsoever would be given to our sponsor. So try this at home. So find the angle of intersection between the curves. X plus 2y plus 3 is equal to 0 and y is equal to the square root of x. So thank you so much for listening, and this is your Casaligan Vlogs. God bless everyone.